The floor is lava! Haha, just kidding. But honestly, it's kind of falling apart. You might not feel it yet, but a huge part of North America has already lost 37 miles worth of rock from its foundation. And no, this isn't about earthquakes or giant sinkholes. It's about the continent losing pieces of the very thing that keeps the ground from wobbling around like a bad carnival ride. A team of researchers has just dropped a geological bombshell. Part of North America's ground is thinning out like a very sad, very slow ice cream drip. How do they know? They basically gave Earth a high-tech full-body MRI and created 3D maps showing how rocks once considered indestructible are now melting away into the planet's guts, like an upside-down cheese pizza inside an oven. But to really understand this mess, you first have to meet my old friends, cratons. Cratons are like the roots of the continents. They're thick, tough, and ancient. We're talking billions of years old. These bad boys survived meteor impacts, supervolcanoes, and even the tectonic movement of plates. If the plates got into fistfights, for example, you can bet we would see mountain ranges being born. If they got a divorce, drifting apart from each other, then a whole new ocean would be born. All of these things leave scars on the surface of Earth, but the cratons seem to always remain unfazed, like the cockroaches of geology. And since a craton can basically get punched in the face and feel nothing, scientists always assumed these things were nearly indestructible. But then, a group of researchers took their fancy machines to the test and realized that, wait, the cratons are falling apart? How? Enter the Farallon Plate, a really ancient tectonic plate that started to slide under North America's major plate over 100 million years ago. This is a pretty normal process, actually. It's called subduction, and it's how Earth recycles rocks and keeps itself from overheating. This subduction thing has been happening for so long that, by now, the Farallon is almost 400 miles away from the craton, sitting pretty chill at the lower mantle, weirdly close to the outer core of our planet. But the Farallon has been causing trouble, like that one roommate who moved out but keeps leaving weird stuff in the fridge. You see, as it sinks, it tugs on the bottom of North America's foundation, stretching it out and causing pieces to fall off into the deep mantle. And if that wasn't enough drama, the sinking Farallon has also leaked water and carbon dioxide into the surrounding rocks, making the craton even softer and easier to shred apart. Thanks, Farallon. Very cool of you. By studying hundreds of earthquakes across thousands of monitoring stations, scientists have confirmed the story. Big chunks of continental material are dripping downward, thinning the craton by as much as 37 miles. That's more missing rocks than can fit into a milk carton. Sounds dramatic, right? But don't worry. This is happening at a snail's pace. It'll take millions of years for anything noticeable to happen. Your great-great-great-great few grandkids from the distant future might still be standing on solid ground. But don't get too comfy. This thing may not be an urgent problem, but there's another type of sinking that's happening faster than you can say, "Help!" Here's the thing. By 2050, at least 32 major cities in the US, including New York, Baltimore, and Charleston, could be partially underwater. And guess what? This one is mostly our fault. Scientists noticed that since 2007, some cities have been sinking into the ground between 0.04 and 0.08 inches every year. Charleston, in South Carolina, is pulling ahead in the worst way possible, sinking 0.15 inches annually. Sure, these numbers sound tiny and a bit ridiculous, but Charleston is barely 9 feet above sea level, and a little sinking goes a long way when the ocean is breathing down your neck. On really bad flood days, people there have to abandon their cars and basically swim home. This whole phenomenon is called land subsidence, and when you mix sinking land with rising sea levels, you get a disaster cocktail of flooded streets, salty farmland, ghost forests, and a lot of very cranky homeowners. And it doesn't stop with just homes. Infrastructure like bridges, roads, airports, and power plants, all things we rely on daily, are also at risk of serious damage. Flooded electrical grids and sunken highways could cause billions more in economic losses and create major safety hazards for communities. Now, let's be fair. Not everything is humanity's fault. Some of this trouble dates all the way back to the Ice Age. About 12,000 years ago, massive ice sheets covered the northern US. They were heavy, like seriously heavy. The weight pushed the land down, and when the ice melted, the ground didn't just pop back up like a trampoline. Instead, it started playing a weird game of geological seesaw. The places that were squished started rising, and the places that weren't got pulled down. This whole process, called glacial isostatic adjustment, try to say that 3 times fast. But of course, humans found a way to make it worse. Groundwater extraction is a major culprit. Think of it like pulling the stuff out of the mattress. After a while, the whole thing just sags. In places like California's Central Valley, the land is dropping by up to 8 inches a year because we keep pumping out water during droughts. In cities like New York, the problem isn't just water. Skyscrapers themselves are making it worse. Yep, turns out if you stack millions of tons of concrete and steel onto soft ground, it tends to flatten. And in case you're wondering, the total mass of New York City's buildings is around 1.68 trillion pounds. That's about the same as 3.5 million statues of liberty piled up. With so much weight concentrated over a relatively small area, the underlying soils have no choice but to compress over time. And if you thought it couldn't get messier, think again. We've been building dams, which stop rivers from delivering fresh sediment to coastal areas. That sediment is kind of like Mother Nature's way of fluffing the ground back up. Without it, coastal lands are compacting like an old sponge. Plus, when wetlands are drained for agriculture or construction, the peaty soil dries out and collapses. Honestly, it's like the ground just can't catch a break. Scientists also noticed that the areas that used to be lush wetlands are now among the fastest sinking spots in the country, especially along the Gulf Coast. Louisiana, for example, is losing about a football field of land because of this mix of subsidence and rising seas. So what's the end game here for us regular people who just want to live above sea level? Well, it's not looking great. Ghost forests, which are basically drowned woodlands, are popping up. Farmland is turning salty and unusable. And even sunny day flooding, where streets flood without any rain, is becoming a thing. Yikes! Meanwhile, over on the West Coast, California is not exactly winning either. San Francisco and Los Angeles are both sinking, which means that rising sea levels could hit them twice as hard and twice as fast. In some places like the Palos Verdes Peninsula, the ground has been sinking so fast, people over there might as well live like moles. So, is America turning into the next Atlantis? Probably not next week, but without serious action, like cutting back on groundwater pumping and planning smarter cities, at least 500,000 people are in serious danger. And the housing damage could easily rack up a jaw-dropping $109 billion by 2050. In the end, while North America isn't about to sink like a poorly made souffle, it's definitely showing some cracks in the crust. So maybe let's ease up on groundwater pumping, rethink how and where we build, and invest a little more in keeping our feet dry. After all, if the floor really does become lava someday, we're gonna wish we had at least fixed the leaks first.
Consider South America and Africa. Don't they kind of look like they fit together, like puzzle pieces? Well, they actually did. But about 130 million years ago, South America was like, bye, and slowly started drifting away. These days, it's around 1,800 miles from Africa, and it's still on the move. Every year, the continent shifts a little more toward the Pacific Ocean. So, how's that even happening? Tectonic plates are constantly moving. That's what makes the Earth's surface shift over time, going from this to what we see today. But those movements happen so slowly that you and I can't see them go. So, no, Brazilians or Chileans aren't out there feeling their continent inching westward. But the numbers don't lie. South America is moving, and apparently all it wants is to get as far away as possible from this massive underwater mountain range called the Mid-Atlantic Ridge. But what exactly is pushing the land toward the Pacific Ocean? It is the heat inside our planet. Way down beneath the ocean, there are cracks in the Earth's crust, and magma, super hot melted rock, rises up through those cracks. When that happens, the magma cools and hardens into solid rock. Over time, this process might build underwater mountains, like the Mid-Atlantic Ridge. And as more new crust forms, it begins to push the older crust out of the way. In the process, tectonic plates and the continents riding on top of them get pushed along. Now, on the other side of South America, over by the Pacific, there is the Nazca Plate. It's heavier and it's moving eastward. Since it is denser, it is sliding underneath the South American Plate. This entire process is called subduction, and it's happening at a rate of about 3 inches per year. By the way, the collision between these two plates is what's behind all those breathtaking volcanoes scattered throughout the Andes, and it's also making the continent move. So, if everything goes according to plan, projections show that South America will end up more centered in the Pacific Ocean in the future. But some models suggest something way crazier. Before we get into that, though, we need to clear something up. Why on earth isn't Africa following in South America's footsteps? I mean, shouldn't it be drifting west too? Well, not quite. Africa is doing its own thing, because it sits on the African Plate. So the Mid-Atlantic Ridge is located between those two continents, and just like it pushes the South American Plate, it also pushes the African Plate, but in the opposite direction. It's like this ridge is trying to split up two ex-besties, you know? But there's more. Africa is also being influenced by the East African Rift. That's one of those massive cracks we talked about earlier, but it's happening on land, which makes it extra dramatic. This is what's causing the continent to slowly split apart. It's a long story, but let's just say the rift is pulling Africa in more directions than South America ever had to deal with. Okay, now it is finally time to talk about that crazier thing that might happen to South America and everything around it in the future. Theory number 1. It could break away from North America. I know, super dramatic, but don't panic. We're talking hundreds of millions of years from now, and I won't be around. You see, both continents are moving in the same general direction, but at different speeds. The North American Plate is cruising along at about 1 inch per year, while South America is moving a bit faster. So even though they're heading the same way, they are not keeping pace. Over time, as the Atlantic Ocean continues to widen and the Pacific keeps shrinking, all this tectonic movement could eventually pull the Americas apart. Theory number 2. Marine life could go through some major changes. Right now, the Americas act as kind of a giant wall between the Atlantic and Pacific Oceans. Because of that, sea animals have evolved differently on each side. Take the green sea turtle, for example. The ones living in the Atlantic tend to be bigger and lighter in color. Meanwhile, their Pacific cousins are usually smaller and darker. But if, one day, there is no land blocking these two populations from mixing, they would end up with brand new migration routes, new nesting spots, and a lot more overlap in their territories. Now, multiply that scenario by hundreds of other species, and things could really get shaken up. We're talking about new interactions, unexpected competition, and maybe even the rise of entirely new species. Alright, theory number 3. America might meet Africa again. Right now, the Mid-Atlantic Ridge is busy creating a new seafloor, and because of that, the Atlantic Ocean is slowly getting wider. But in about 125 million years, scientists believe that process could come to a stop. Instead of the seafloor spreading apart, the ocean floor might start getting pulled under the continents. When that happens, the Atlantic will stop growing and start shrinking, and the water section between South America and Africa is likely to be the first part pulled beneath the land. That means the Americas and Africa could meet again. And when that happens, border countries could turn into super shaky places, with earthquakes happening all the time and brand new volcanoes popping up left and right. The eastern United States would no longer be known for the peaceful green slopes of the Appalachians, but for snow-covered giants that occasionally spew lava and ash, more like the Cascade Range out west. Countries would end up with totally new neighbors. Brazil might line up with Nigeria and Cameroon. Uruguay could be sitting right next to Angola. And Argentina might be sharing a border with South Africa. So if these two continents really do merge, how intense would that be? Well, for starters, this new supercontinent would instantly become the biggest one on Earth, about 1.5 times the size of Asia. And chances are, a brand new mountain range would form right where the continents meet, creating a natural border between nations. Being part of the same massive continent could make a lot of things way easier. For one, tourism could totally take off. People traveling between countries by land without needing pricey plane tickets could be a game changer. But it wouldn't stop there. Other types of economic activity could get a major boost too. Now on one side we have South America, which already produces and sells a wide variety of foods, from wheat to bananas, beef, cocoa, soybeans, hey, you name it. On the other side, there is Africa, exporting things like textiles and clothing. That alone would make them a super powerful bloc when it comes to trading raw goods. But can you name another important thing these two continents have in common? Yep, petroleum. Countries in South America, like Brazil, Venezuela, and Colombia, are major oil exporters. And over in Africa, you've got Nigeria, Algeria, and Libya doing the same. Now, can you see just how powerful that kind of union could be? Meanwhile, let's talk about animals. These two massive lands coming together could lead us to wild meetups, like a capybara sharing space with a Nile crocodile, or a sloth seeing a hyena from the top of a tree. This could even lead to new animal hybrids showing up, like a cabby crocodile or a sloth hyena. Okay, those weren't the cleverest names, and honestly, these animals wouldn't be able to mate or even wouldn't want to. But you get the point, right? It's not all positive, unfortunately. New species showing up could become predators, competitors, or even parasites to the native plants and animals. It would take a long time for things to settle into a new balance in those border regions. But honestly, no one really knows how long it would take. The only thing I do know is neither of us will be around to see it, which is okay.
This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries, like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott Caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers, who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives. A giant crack, more than 2,000 miles long, is splitting open across Africa. Roads, houses, even schools are getting torn apart. Now, scientists think they've finally figured out what's causing it. An enormous column of scorching hot rock called superplume, rising from deep inside the Earth. And it's slowly pushing the land apart inch by inch. This isn't a small shift though. The continent is breaking in two, and the clue to what's going on could be hidden thousands of miles away in Hawaii. And why does the United States suddenly have a role in all of this? Hang on, we'll get there. First, it's important to know this isn't new information. Africa has been slowly splitting for about 25 million years. This is happening in a region called the East African Rift System. It stretches thousands of miles from Ethiopia down to Mozambique and is the largest active continental rift system on the planet. And by that, I mean places where the Earth's crust is being stretched and pulled apart, causing faults, earthquakes, and volcanic eruptions. Scary stuff to say the least. Back in 2018, for example, a massive crack appeared near a small town just west of Kenya's capital, Nairobi. In some spots, it was about 65 feet wide. That's almost the length of two school buses parked one after the other. The whole thing was terrifying. It happened fast and left a trail of destruction. Roads were cut off, farms torn apart. People were on edge as the ground opened up beneath their feet. And I mean that quite literally. One man watched the crack rip straight through his home. He barely had time to grab a few of his belongings before his entire house collapsed. Sounds terrifying, right? Since it happened in the East African Rift region, panic spread fast. The media was all over it, claiming it was proof that Africa is splitting apart. People standing near the crack thought, oh boy, it's already happening. And many still believe that today. But that's not actually the case. At least not with that particular crack. Because after the initial panic, videos and photos of it revealed clues that it wasn't related to tectonic plate movement. First clue, the two sides of the crack didn't match. Like trying to fit the wrong puzzle pieces together. They simply didn't line up. Second clue, the gap wasn't one continuous line. There was some kind of soiled bridges in between. All this showed it was sudden erosion. I mean, some specialists believe the crack had once been filled with volcanic ash from nearby Mount Longonot. But then the region was hit with heavy rains. When water soaked through the soil, it washed the ash away, leaving the gap exposed. Problem solved. Even after the truth came out, it was too late. This event brought the whole Africa is splitting talk back. And here's the thing. Even though that crack had nothing to do with it, make no mistake, Africa is breaking apart. That's because the continent sits between two tectonic plates, the Somali plate in the east and the Nubian plate in the west. The problem is they're moving away from each other, and as they drift apart, the gap in the East African Rift keeps getting wider. Eventually, the Somali plate could split completely from the Nubian plate, creating an entirely new landmass, something on the scale of Madagascar or even New Zealand. You don't have to worry though. This process is super slow. So slow that none of us will see it finished. Experts say the continent is moving apart by about 0.3 inches a year in some places. To give you an idea, that's less than the length of your fingernail. So we can say this split will take millions of years, which is good news for the people living there. But that doesn't mean they won't feel the effects of this slow break. In fact, they're already happening. Take Ethiopia's Afar region, for example. Back in 2005, this area showed just how unpredictable the rift can be. In a short period, 420 earthquakes hit the area, opening up a massive fissure. What usually takes centuries happened in just a few days, completely challenging what scientists thought they knew about the speed of geological changes. Back then, the crack stretched for more than 35 miles, and life around it is still far from easy. Recent earthquakes destroyed much of the local infrastructure. 37 schools were damaged, leaving 5,000 students without classrooms. And that was just one part of the damage. As the tectonic plates keep moving apart, water will eventually flood into this region, creating a brand new ocean, according to some predictions. Countries like Zambia and Uganda, which are landlocked today, could one day have a coastline. That could be great news for them, as it might open up new trade routes and completely reshape their economies. Don't get too excited though. We won't be diving into the waters of this sixth ocean anytime soon. The splitting process will take another 5 to 10 million years. But it's tough to say exactly when, since big seismic events, like earthquakes, could make it all happen faster. So here's what we know. The Somali Plate and the Nubian Plate are in the middle of a dramatic tectonic breakup, slowly moving apart. Africa is breaking in two. Earth will probably gain a new ocean because of it. But until recently, we didn't know exactly what was triggering all of this. Like, yeah, those tectonic plates are moving, but why? I mean, is this massive geological process being driven by something happening in Earth's mantle? Or could it have a much larger, deeper source? Well, scientists think they may have finally cracked the mystery. They believe the continent is breaking apart because there's a deep mantle superplume, a huge column of hot rock beneath the East African Rift system. Think of it as a massive subterranean hammer pushing upward, pressing against the crust, and slowly cracking it apart. But here's the interesting thing. Scientists reached that conclusion thanks to something that happened in a completely different part of the world, Hawaii. Under this US state, there's also a plume of super hot rock rising from deep inside the planet. It melts the crust above it, and that's what fuels Hawaii's volcanoes. As the Pacific Plate drifts over this plume, molten rock breaks through in new spots, creating volcano after volcano. Over millions of years, that's how the Hawaiian Islands were formed. This Hawaiian plume contains noble gases like helium and neon. And you know where else scientists found those same gases? That's right, beneath the East African Rift system. Bingo! That discovery backed up the theory that a superplume is driving what's happening in Africa. And we call it super because it might be massive. You see, these same gases have been found in volcanic rocks from Kenya all the way down to Malawi. So everything points to the existence of a single superplume that stretches from the Indian Ocean to the Red Sea, not a bunch of several isolated sources. If their data and research are correct, scientists estimate that this superplume beneath Africa likely starts at the core mantle boundary, which is located about 1,800 miles deep inside the Earth. While the East African Rift system's chemical signatures are similar to those found in volcanic rocks in Hawaii, they're not identical. The Hawaiian plume is thought to be a narrow, rising stream of hot mantle, a bit like the movement inside a lava lamp. Africa's plume might be shaped differently, more like a large mass of hot, buoyant material rising from deep within the Earth. As it reaches the surface, this hot material hits the colder, solid outer layer and spreads out, pushing hard enough to crack it open and trigger intense volcanic activity across the region. And if this theory is right, we're watching a slow but unstoppable force that will redraw Africa's map and change the continent forever. At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle and not just local eruptions. India could split horizontally into 2 parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept, the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia-Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia-Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where two or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Canyon. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into two subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The two are gradually moving away from one another, which causes the formation of crevices within the rift valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into two continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today.
Deep inside our planet, there are two massive blobs of rock that have puzzled scientists for years. They sit deep inside, opposite each other. One lurks under the Pacific Ocean, the other under Africa. And they're so weird, they even make seismic waves slow down. Their actual name is large low-velocity provinces, but they're just two enormous, mysterious blobs of rock, bigger than continents, stranger than anything else inside the Earth, and so dense they might be leftovers from another planet. Until recently, no one knew what they were, where they came from, or why they even exist. These mysterious blobs could hold the secret to Earth's deepest forces, powerful enough to shape earthquakes, drive volcanic eruptions, and even influence the evolution of life itself. And now, we might finally learn the truth about them. These geological monsters are hidden about 1,800 miles beneath the surface. Each one is 100 times taller than Mount Everest, so vast they defy explanation. Now, at first, scientists thought these were primordial remnants from Earth's early days. Maybe something giant smashed into Earth about 4.5 billion years ago, and this impact formed both the Moon and these blobs. Scientists believe it could have been a planet named Theia, a Mars-sized planet that existed somewhere around the asteroid belt and slammed into Earth back in the day. Others believe it could be something much more familiar, old chunks of Earth's crust. Perhaps they got pushed deep into the mantle by the movement of tectonic plates. And now, a new study shows that these blobs are massive piles of oceanic crust that have been sinking into the Earth for billions of years. They could have formed from the stuff that sinks into Earth when tectonic plates collide. Over 1 billion years, pieces of ocean crust could have been swallowed by the mantle. Eventually, they collected into two massive regions deep inside the planet. But even though both blobs form the same way, they aren't identical. There's this place called the Pacific Ring of Fire, a giant loop of volcanoes and earthquake zones around the Pacific Ocean. Well, the Pacific blob doesn't just stop growing and changing because it's constantly being fed fresh rock from that place. Tectonic plates crash into each other, and one plate sinks beneath another, pushing old ocean crust deep into the Earth. Since this keeps happening, the Pacific blob is heavier, denser, and more active than its twin under Africa. It's like a giant hot rock factory, constantly getting new material and reshaping itself over time. The African blob is much older and quieter than the one under the Pacific. It doesn't get fresh rock pushed into it as often. That's why, over time, it has blended more with the surrounding mantle. Since it's less dense, it behaves differently. It rises higher into the Earth's mantle, stretching 340 miles closer to the surface. And that might be why Africa has so many powerful volcanoes and rift valleys today. The biggest question is, how do they keep evolving? Scientists think that huge columns of hot rock, called mantle plumes, might be pushing up from deep inside the Earth, helping to drive the movement of tectonic plates in the Pacific. If they're right, then these giant underground blobs aren't just sitting there. They're almost alive in a way. They'd be constantly changing and shaping the surface of our planet. But why do they even matter? Because these weird underground structures may be shaping Earth's surface in ways we don't fully understand yet. You see, first, they might influence Earth's magnetic field. That's because they affect how heat moves through the mantle and core. They might also hold clues about the history of plate tectonics. Studying them could help us figure out when subduction began on Earth, whether it was over 4 billion years ago or much more recently. These guys might also be secret puppet masters behind volcanic activity. There's a theory that blazing hot rock from deep inside the Earth, the same kind that creates volcanic hotspots, might be rising straight from the giant blobs in the mantle. Some of the biggest volcanoes on Earth, including those in Hawaii, Iceland, and Yellowstone, sit directly above the suspected rising plumes from these blobs. If these blobs are fueling these volcanoes, then they could be responsible for shaping Earth's continents, climate, and even mass extinctions throughout history. And well, that's horrifying. That would mean that these giant structures might burst through Earth's crust one day, unleashing catastrophic supervolcanic eruptions, and these eruptions would last for millions of years. Beneath the Earth's surface also lies monsters unlike anything else on this planet – supervolcanoes. They're so massive, so destructive, and so rare that no human has ever witnessed one erupt. A regular volcanic eruption can be terrifying. Lava spewing into the sky, ash choking the air, entire cities buried under fire and stone. But a supervolcano? Well, that's something else entirely. A supervolcano isn't just big, it's a category of its own. Their eruptions rip apart the Earth itself, creating massive craters called calderas. Some of them are over 30 miles wide. A regular volcanic eruption might spew out a few cubic miles of lava and ash. A supervolcano unleashes more than 240 cubic miles of material. That's enough to bury an entire continent in ash. An eruption like this would be newsworthy, to say the least. First, a wall of fire would blow up into the sky. Ash would block out the sun for years, dropping global temperatures. Entire countries could be buried under meters of ash, making farming impossible. Famine, extreme cold, and toxic air could wipe out entire civilizations. It wouldn't just be a local disaster, it would be global. In fact, 2 of the worst mass extinctions in Earth's history, where almost all life was wiped out, might have been caused by supervolcanoes, not asteroids. The biggest and most horrifying one was at the end of the Permian period. Literally, about 90% of all marine species and 70% of land species went poof. Scientists have counted about 20 supervolcanoes on Earth today. The most famous ones are Yellowstone in the US, Toba in Indonesia, and Topau in New Zealand. Now, the last time Yellowstone erupted was roughly 2 million years ago. It released almost 590 cubic miles of material, enough to bury a city like New York. That was just one of 3 Yellowstone supereruptions. The most recent supervolcano to erupt was Taupo in New Zealand. This happened about 26,500 years ago. But supervolcanoes don't just destroy, they reshape the entire planet. About 74,000 years ago, the Toba supervolcano erupted in Indonesia. Some scientists believe it triggered a volcanic winter that lasted an entire decade. There are also theories that suggest that this eruption nearly wiped out early humans. It reduced their numbers to just a few thousand survivors, although that's just speculation. Either way, we know for sure that supervolcano eruptions have changed the course of history. So, how do we prepare for them if this could happen at any moment? Well, scientists monitor volcanoes constantly, looking for warning signs. It could be stuff like rising magma, ground swelling, earthquakes beneath a volcano, changes in gas emissions, and so on. The problem is that while we can predict short-term eruptions, the long-term ones are still a mystery. Yellowstone last erupted 630,000 years ago. It's literally overdue for another eruption already. But volcanoes don't work like clocks. Just because one erupted in the past doesn't mean it will definitely go wild again, and the time between eruptions could be random. Scientists think Yellowstone could erupt again, but it might be just a small lava flow instead of a super eruption. Are we ready for a super eruption if it happens? Probably not. Scientists say we're more prepared for an asteroid strike than a supervolcano eruption. When Hunga Tonga Hunga Ha'apai erupted in 2022, it cut off communications, caused tsunamis, and filled the sky with ash. And that was only a magnitude 5 eruption. A supervolcano would be orders of magnitude worse. So, good luck sleeping at night knowing these guys will erupt again. Maybe tomorrow, maybe in 100,000 years. Nah, don't lose sleep over it.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank 1 bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for 2 main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, A series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia subduction zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
So, you've just finished your sightseeing tour of Edinburgh, Scotland, or Scotland. It lasted just under an hour, and you're hungry for more. You ask your guide if there's anything else to see, and they start talking about a mysterious underground city. You ask how long it takes to get there, and you're shocked by the guide's answer. You're standing on it. It's right under your feet. South Bridge? But you were just there and didn't notice a giant arrow pointing down. So this is where the mystery starts. The story begins in the mid-1700s. The Scottish capital wasn't as big as it is today. Only 60,000 people lived around Edinburgh Castle. All of them were packed inside medieval walls, and they say today's cities are overpopulated. Get a load of the living conditions back then. The buildings were tall, so there was little natural light. Some houses had 14 stories. Cows walked the narrow winding streets and left stuff. Things were so bad that the famous English writer Daniel Defoe noted, "I believe that in no city in the world so many people have so little room." Yep, that's the guy who wrote Robinson Crusoe. Well, something just had to be done. The solution was to build 2 long bridges to the north and to the south of the city. The names they gave the bridges were more descriptive than colorful. The bridge to the north was completed first. In 1785, construction on the second bridge got underway. It was going to connect the main pedestrian street in the north with the university buildings in the south of Edinburgh. But don't think of this construction as a modern bridge over a river. It was more of a viaduct, a type of bridge that connects 2 hills across a valley. The word viaduct comes from Latin, as Romans were pioneers in building these structures. Their capital was built on 7 hills. And just to be copycats, Edinburgh also straddled 7 major hills. Only 2 are visible today because the city has been built up. Now, back in the 18th century, the construction of the South Bridge was a remarkable feat of engineering. It took the builders only 3 years to complete it. 19 stone arches spanned a chasm that was 31 feet at its deepest point, and the length over 1,000 feet. Impressive, even for today's standards. But what does a 2.5 centuries old viaduct have to do with an underground city? Well, it is the city. You see, they designed Southbridge to be hollow on the inside. As you walk along this street today, there is actually a huge human-made cave beneath your feet. The popular name for this set of chambers is the Edinburgh Vaults. But what was the purpose of this space? And is there something or someone there now? Well, let's take it one step at a time. The builder's original intention was for these vaults to serve as merchant shops. At first, it worked out fine. Merchants used a total of 120 vaults as shops and warehouses. There were workshops, cobblers, and taverns. But as time went by, a major design flaw came to light. The stone was leaking, and the vaults were damp all the time. There was even flooding. The builders forgot to waterproof the structure. The merchants feared the water would damage their precious goods. After just a couple of years, the first tenants started moving out. Once legal trade moved away from the vaults, the city's poor moved in. And not only them, but all sorts of shady characters. Historians don't know much about this period, since there are no written records. But even the squatters had to leave soon. If you couldn't do business in these vaults, how could you live in them? It was damp and cold, and there was no ventilation, sanitation, or natural light. It really stunk. Every real estate agent's worst nightmare. Just 30 years after their completion, the Southbridge Vaults were abandoned once and for all. But at a street level, business was as usual. The officials decided to fill the vaults with rubble for security purposes. Buried and forgotten, the memory of a once teeming merchant quarter of Edinburgh slowly faded from people's minds. Now, this is where the story gets a bit weird. During the 1980s, a Scottish rugby player accidentally found a tunnel leading into the vaults. The athlete didn't waste any time and started excavating the vaults with the help of his son. Several tons of rubble, and a decade later, the Southbridge Vaults have been restored to their former glory, so to speak. They were again dark and damp as they were back in the 1700s. There were many interesting finds in this underground city. The vaults were littered with oyster shells, which were the standard diet for a working-class resident of Edinburgh at the time. Other finds, such as shoes and empty bottles, suggested that people actually lived in these claustrophobic vaults. Think of this the next time you see someone trying to rent their garage as an apartment. So, your guide was right. There really is a hidden city under the streets of Edinburgh. Well, at least one street. You have now gone down from the main pedestrian street into Cowgate. You look up and there it is, the only visible arch of the once impressive bridge. You are now searching online to book a tour of the vaults. You just have to see this place with your own eyes. But the Scottish capital isn't the only city with a mysterious underground. The historic region of Cappadocia in central Turkey hides no less than 36 cities beneath the ground. The biggest and the most impressive one wasn't discovered until 1963. It was built during the Byzantine era to protect the local population from invaders. We have similar structures made out of concrete in our cities, but the level of the Turkish underground city is really impressive. There are several levels, like in a multi-story car garage. The caves and tunnels lie 197 feet underground. That's 2/3 of the Statue of Liberty's height. The city could house 20,000 people at any given time, complete with livestock and food. The smell. Anyway, 20,000 is the average attendance at Major League Soccer matches today. You might want to add a field trip to one of these places the next time you go to Turkey. Most of these cities in Cappadocia can be found in rural areas. Makes sense, right? After all, they were dug out as hiding places. But in Europe, there is one city whose underground labyrinth resembles the vaults of Edinburgh. You've probably heard of Pilsen in the Czech Republic. But hold on a second, this isn't going to be a story of the most famous local product, something brewed, perhaps? It's the story of a medieval city that survived underneath the streets of Pilsen. Water wells, cellars, and passageways stretch for more than 12 miles. Merchants and craftspeople used Pilsen's historical underground for storage. Water, food, ice, you name it. The waterworks are pretty impressive. Historians estimate that 360 wells are located under Pilsen's historical town center. In times of instability, the passageways served as safe havens for the locals. They definitely didn't go thirsty down there. Today, most tourists visit these mysterious underground cities. But in Canada, there's one where people live and work. The construction of Montreal's underground city began in 1962. The initial idea was to shelter traffic. That's a nice way to say that city officials were building a metro station. The idea caught on and the project expanded. Now, it's a real-life urban maze hidden under the downtown area. Need a place to stay? There are hotels down there. Want to grab a bite? Step into one of the underground restaurants. Multiple shops, a library, cinemas, the list is long. There are even residential complexes. But how can people live under the ground? Simple. Although the city itself lies beneath the earth, the access points are at ground level. You can enter the 20-mile-long tunnel network at more than 120 places. Oh, that's another place down under. Oops, sorry, Australia. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's the reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha! Loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Pollan claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Pollan and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster. Park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 super eruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent super eruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot, expanding gases. It looked like an extremely hot, toxic snow avalanche. With a temperature of about 1,300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sunblocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.